Determine the length of the intercept on the straight line 2x minus y minus 5 equals to 0 by the circle whose equation is given to us. Let us begin. So here what we have is a circle and its equation is given to us. Let us suppose that the circle is centered at point C. Now we have a straight line which intersects the circle at 2 points. Let's call those points as point A and point B. Our goal will be to determine the length of the intercept of the straight line. That means length of AB. AB is the intercept. Right. So here what we'll do, we'll start with the equation of the line. The equation of the line, which is 2x minus y minus 5 equals to 0. What we'll do, we'll isolate y from here to get y equals to 2x minus 5. We're going to let this as equation number 1. Now, we'll also consider the equation of the circle, which is x squared plus y squared minus 6x plus 8y minus 5 equals to 0. So what is our goal here? Our goal here will be to first determine the coordinates of point A and point B, and once we have the coordinate value, we can use the distance formula to find out the length of the intercept. To find out the coordinates of point A and B, what we'll do, we'll substitute the value of y, which is 2x minus 5, obtained from the equation of the line, into the equation of the circle. That means we will get x squared plus, now in place of y squared, we have 2x minus 5 whole squared minus 6x plus 8y. So what's y here? Y is 2x minus 5 minus 5 equals to 0. We get, now when we simplify this particular equation, we're going to get a quadratic equation, x squared minus 2x minus 4 equals to 0. Now what we can do, we can use the standard formula for finding out the roots of a quadratic equation. We're going to get x equals to 1 plus or minus square root of 5. Now that we have the values of x, what we can do, we can use the corresponding y value. So let's start. We will use equation number 1. So when we have x equals to 1 plus square root of 5, then the corresponding y value will be equals to minus 3 plus 2 times square root of 5. So this is going to be a coordinate point, 1 plus square root of 5, and the y coordinate is negative 3 plus 2 times square root of 5. We're going to assume that this is the coordinates of the point A. Next, we choose the other values of x. When x equals 1 minus negative square root of 5, then the corresponding y value, that's going to be negative 3 minus 2 times square root of 5. So let's say this is the coordinates of point B. So we have 1 minus square root of 5, comma, negative 3 minus 2 times square root of 5. So now we have the coordinates of point A and point B. To find out the length of the intercept, which is nothing but the length of AB, we can use the distance formula. So we'll take the square root. Underneath the square root, first we need is the difference of the x coordinate. So we do 1 plus square root of 5, and from here we're going to subtract the x coordinate of point B. So that's negative 1 plus square root of 5. We're going to square this result and then add it to the difference of the y coordinate. So we consider the y coordinate of point A. So that's negative 3 plus 2 times square root of 5. And from here, we're going to subtract the y coordinate of point B. So that's positive 2 plus 2 times square root of 5 whole square. That will be equals to, we take the square root. So here 1 and 1 gets cancelled. Square root of 5 plus square root of 5, that's 2 times square root of 5. Let's write it down, 2 times square root of 5 whole square. Then we have negative 3 and positive 3 cancelling out. So we get 4 times square root of 5 whole square. So this was going to give us square root of, we have 2 times square root of 5 whole square. So that's simply 20. So we have 20 added to 16 times 5. So that's going to be 80, which is simply square root of 100. That's nothing but 10. So that means the length of the intercept is going to be 10 units.